Hi everyone, welcome to this lesson where we will learn about Amazon SQS and Amazon SNS. I am Aishwarya Sood. I am a software engineer and AWS trainer by profession. I am AWS Certified Cloud Practitioner, AWS Certified Solutions Architect Associate, AWS Certified Developer Associate, and also AWS Academy Accredited Educator. You can connect with me on LinkedIn at this profile name, that is Aishwarya Sood 29. You can also scan the QR code to quickly view my profile. In this video, I'll explain the concept of message queues, their requirements and benefits. I'll also explain briefly about Amazon SQS, producers, consumers, the types of queues in SQS, message lifecycle and more. We will also see the working of Amazon SQS and the later part. Along with SQS, we will also look into the process of pub/sub messaging, Amazon Simple Notification Service, also known as Amazon SNS, SNS topics, publishers, subscribers, and a sample architecture using SNS. Then I'll demonstrate the working of Amazon SNS as well. Before knowing what a message queue is, let me tell you about the terminology. We have messages produced by various services, applications, users, and processes. Whenever there is a need to collect, process, or take action on a message, we can queue these data, that is messages, in a message queue. The messages are usually small and can be things like requests, replies, error messages, or just plain information. To send a message, a component called producer sends a message to the queue. The message is stored on the queue until another component called the consumer retrieves the message and does something with it. A message queue is a form of asynchronous service-to-service communication used in serverless and microservices architectures. It provides a lightweight buffer which temporarily stores the messages and endpoints that allow software components to connect to the queue in order to send and receive the messages. Since this is an asynchronous communication, this means both the entities, that are producer and the consumer, do not need to be present together to perform a task. Producer will send the message which will be stored in the queue, and consumer will pull the message from the queue and process it. Messages are stored on the queue until they are processed and deleted. Each message is to be processed only once by a single consumer. Once the consumer processes a message, the consumer has to explicitly delete it, since it will not be deleted automatically from the queue. Message queues can hence be used as a great solution to decouple heavyweight processing. Many producers and consumers can use a queue, but each message needs to be processed only once by a single consumer. For this reason, this messaging pattern is often called as one-to-one communication. But what's the need for a message queue? Have a look at this architecture. There's a website which is named as www.mywebsite.com. It's a two-tier architecture in which we have a web tier and an application tier. Web tier is handling all the front end, whereas the application tier is containing the actual programming logic of the application. All the three servers of the web tier are dependent on all the three servers of the application tier. This is a tightly coupled architecture, but this is a bad practice. What are the problems associated with it? First is complexity. This architecture just contains three servers in each tier, but bigger applications, like when the application is even bigger, the number of servers will be even more. Then the architecture will become too complex, and that time, because of which there will be difficulty in resource management as well. Secondly, what if any resource in this architecture fails? Let's say one of the instances in the application tier fails. This will affect all the instances in the web tier because they are dependent on the failed instance. Let's say if the database itself fails, there can be certain issues because of the database, because of which the database is failing. This will affect all the servers in the app tier, and this will eventually affect all the servers in the web tier, and thus the entire application will fail. The next problem will be difficulty in scalability. In a tightly coupled architecture, it will be hard to scale the resources because of the complex dependencies. If you add or remove servers at one layer, every server on every connecting layer has to be connected appropriately also. Let's look at few more benefits of message queues. First here is decoupling. Message queues remove dependencies between components and significantly simplify the coding of decoupled applications. Software components aren't weighed down with the communications code and can instead be designed to perform a discrete business function. Message queues are an elegantly simple way to decouple the distributed systems, whether you are using a monolithic applications, microservices, or serverless architectures. Use message queues to decouple your monolithic applications rather than performing multiple functions within a single executable. Multiple programs can exchange information by sending messages between processes, making them easier to test, debug, evolve, and scale. The next advantage is asynchronous processing. Message queues enable asynchronous communication, which means that the endpoints that are producing and consuming the messages interact with the queue, not with each other. Producers can add requests to the queue without waiting for them to be processed. Consumers process the messages only when they are available. No component in the system is ever stalled waiting for another, optimizing the data flow. And message queue enables a granular scalability because message queues make it possible to scale precisely where you need to. When workloads peak, multiple instances of your application can all add the request to the queue without the risk of any kind of collision. As your queue gets longer with these incoming requests, you can distribute the workload across a fleet of consumers. Producers, consumers, and the queue itself can all grow and shrink on demand because this is a managed service. And since after decoupling the architecture with the queue, dependencies will be reduced. This will enable better fault tolerance in the entire architecture, and having all the above features in your architecture will lead to a better overall performance of the application. Now let's see what exactly is Amazon SQS. Amazon SQS is a fully managed message queuing service, which means you can enjoy all the benefits of message queues on the solutions that you deploy or build on AWS. Amazon SQS supports dead letter queue. In case any message on the queue was unable to be processed even after retrying for the maximum number of attempts allowed, it will be stored in a dead letter queue from where it can be pulled. It can be pulled, troubleshooted, and also processed later. A DL queue is just like any other Amazon SQS queue, and messages can be sent to it and received from it like any other Amazon SQS queue. There are two types of SQS queues, which are standard queue and the FIFO queue. FIFO stands for first in and first out. Standard queues offer at least once delivery and best effort ordering. At least once delivery means a message will be sent for once for sure, but occasionally more than one copy of message can be delivered. Standard queue will always try its best to maintain the order of the messages but does not guarantee it. FIFO queue stands for first in first out queue. As the name suggests, this queue will always keep the original order of the messages. The messages that came first will be processed first. Also, messages are processed exactly once. This means there will be no copies of the messages if you are using a FIFO queue. SQS is a poll-based messaging. This means the producer will send the message to the queue and the consumer will have to pull it from the queue in order to process the message. It will not be delivered to the consumer automatically. Then visibility timeout. It is a period of the time that a message is invisible to the rest of your application after an application component gets it from the queue. During the visibility timeout, the component that received the message usually processes it and then deletes it from the queue. This prevents multiple components from processing the same message. When the application needs more time for processing, the invisible timeout can be modified. That is, a visibility timeout duration can be modified. So this is the message life cycle of an Amazon SQS message. This scenario completely describes the life cycle of an Amazon SQS in a message in a queue from creation to deletion. A producer, that is a component 1, sends a message, that is message A, to the queue, and the message is distributed across the Amazon SQS servers redundantly. When a consumer, that is component 2, is ready to process the messages, it consumes message from the queue and message A is returned and the visibility timeout starts. While message A is being processed, it remains in the queue and isn't returned to subsequent receive request for the duration of the visibility timeout. The consumer component 2, this component 2, it will delete the message A after processing from the queue, and it prevents the message from being received and processed again when the visibility timeout expires. There's a case when Amazon SQS automatically deletes a message. It is when a message has been in the queue for more than the maximum message retention period. The default message retention period for a message is 4 days. However, you can set the message retention period to a value from 60 seconds to 14 days. Now let's see how Amazon SQS actually works. So I have logged into my AWS console and we will navigate to the SQS, that is simple queuing service. So here we will create a queue and we will see how it actually works. Let's create a new queue in the Amazon SQS and let's see what are the settings here. So there are two types of queues. You can select any one type from the standard and the FIFO queue. For now, let's select the FIFO queue, and to create a FIFO queue, we have to give the extension .FIFO. So I have given the name myqueue.FIFO to my queue. Here I can set the visibility timeout, as I explained on the slides, that it will be the timeout when the message will be invisible to all other consumers if it is getting processed by some consumer. So here I can change the visibility timeout settings, and message retention period is the time for how long the message should stay in the queue. You can change it from here. I will leave it as default. Delivery delay also you can specify in seconds if you want the message to be delivered with a delay. And maximum message size you can also specify. It is maximum of 256 KB. It can be anywhere between 1 KB and 256 KB, and it can be changed from here. Receive message wait time. If you want before a message should be received in the polling, you can specify a value that is greater than 0 here. And we will also enable the content based deduplication for the FIFO queue. And other settings, let us leave them as default and click on create queue. So my queue has been created, and let me now try sending and receiving the messages from my queue. Let's click on send and receive messages. So I will send a message. Let me enter a message body. And message group ID also I have to give a message group ID, because all the messages that will be sent within a group, they will be ordered and they will be processed in the exact order that they have been received. So yeah, the things are optional. I can send the message. My message has been sent, and let me now receive the message. I will have to poll for this message. So click on poll for messages. So here comes my message that I have just sent. I can open it, I can view, I can process it. So these are all the details when the message was sent, and all other details, all other attributes that we have set, like the message group ID. I entered 1, so it is displayed here. Done. So I have seen the message the consumer can process, and we have to explicitly delete it. Let me try deleting this message. So it couldn't delete one message, I think because the message has been expired, but you can delete this message by following the same process after you have processed this. So this is just a small demo for how to just set up a queue. You have to set up a queue like this. You can make configuration changes wherever you want, and you can now use this queue within your architecture to decouple your architecture. So this was how the Amazon SQS basically works, and let me get back to the slides. Let's learn about next type of messaging, that is pub/sub messaging. So we have seen the message queues working, but there's one more messaging type, that is pub/sub or publish subscribe messaging. So the publish subscribe messaging or pub/sub messaging is a form of asynchronous service to service communication used in serverless and microservices architectures basically. In this model, a publisher sends a message to the topic. Amazon SNS matches the topic to a list of subscribers who have subscribed to that topic and delivers a message to each of those subscribers. Each topic has a unique name that identifies the Amazon SNS endpoint for publishers to post the messages and subscribers to register for notifications. Subscribers receive all messages published to the topics to which they subscribe, and all subscribers to the topic receive the same messages. You can relate it with the YouTube channel, like creator will create a YouTube channel and multiple subscribers will be there for that particular channel. Whenever a new video is published to that channel, all the subscribers who have subscribed to the channel, they will get a notification. So this is a kind of same processing here. Amazon SNS, let's see how the Amazon SNS works and few facts about Amazon SNS. So SNS also stands for Simple Notification Service. To implement the PubSub messaging for solutions on AWS, we have to use a Amazon SNS. It has a push mechanism. This means a message will be sent to the topic and it will be automatically delivered to the subscribers of that topic, unlike SQS where the consumer has to pull a message from the queue to process it. There can be various subscribers for an SNS topic, like email, where the text messages can be sent to the registered addresses as the email. The other subscriber can be HTTP or HTTPS, where the subscribers specify a URL as a part of the subscription registration. The notifications will be delivered through an HTTP post to the specified URL if you have subscribed through the HTTP or HTTPS. You can also subscribe to SMS, where messages are sent to the registered phone numbers as SMS text messages. And SQS queue can also subscribe to an Amazon SNS topic, in which users can specify an SQS standard queue as the endpoint, and Amazon SNS will enqueue a notification message to the specified queue. Furthermore, the messages can also be delivered to AWS Lambda functions for handling message customizations, enabling message persistence, or communicating with other AWS services. Few use cases of SNS include push notifications, application or system alerts, or it can be used for further use cases also. You can explore more use cases. For example, you could receive immediate notification when an event occurs, such as a specific change to your auto-scaling group in your AWS account. You could use Amazon SNS to push targeted news headlines to subscribers by email or maybe by SMS. Upon receiving the email or SMS text, interested readers could then choose to learn more by visiting a website or launching an application. You could send notifications to an application indicating that an application update is available. The notification message can include a link to download and install the update. The message order and delivery is not guaranteed in SNS, which means once the publisher sends a message to the topic, it will be sent to the subscribers of that topic immediately in any order, but it can't guarantee that the subscriber has received the message successfully. Maybe because of some network issues, the subscriber would have missed the notification or the message. Now let's see a sample architecture using SNS. So in this example, the first component here is the EC2 instance, who is a message publisher here. This instance is publishing the message to the SNS topic. The subscribers of that topic in this case are Amazon SQS queue, an AWS Lambda function, and an HTTP endpoint. All of the subscribers will receive the exact same message whenever whatever gets published to the topic. So this EC2 instance will publish the message here, and all the subscribers that are participating, all the subscribers who have subscribed to this SNS topic, they will be getting exactly same message once it is published to the topic. Now let's see how Amazon SNS works and how to configure SNS topic, how to create the subscriptions, and few more things on Amazon SNS. So we have to first navigate to the service, simple notification service, that is Amazon SNS. Click on this and let's create a topic on Amazon SNS. Click on the topics and create topic. So first we will create the topic and then we can create the subscription for whosoever wants to subscribe to that topic. Here also you can select any of the two types of the topic, that is FIFO or standard. So in this one, let's select the standard for now and let's give it a name. And other settings we can leave it as default. If you want encryption or you want to specify any kind of special access policy or anything, you can add it from here. I will leave all other settings as default and I will create a topic. So here my topic has been created. Now what I will do, I will create a subscription for this topic so that whatever gets published to this topic, the subscribers will receive the message. Let's create a subscription from here. So protocol, I will select email for now, and to give the email, let me get a temporary email. So I have got a temporary email from here, and I will add it as a subscriber. And you can also configure further things if you want. I will leave all the optional settings as default. Click on create subscription, and the email for the subscription confirmation would have been sent to the email that I have got. Let me see if I have received the message. Yes, there's one message. Okay, this is AWS notification subscription confirmation. So I have to open the email and I have to confirm the subscription so that further messages, whatever gets published to the my topic, it will be received to my inbox. Let me confirm the subscription. So the subscription has been confirmed here. I can also unsubscribe if I want to. Let me go back to the the topic, and I will publish a message to see if my subscriber, that is this email, receives the message. So let's send a message to the topic. Let's open this one and publish a message to the topic. So you can also specify the time to live for this message, or how long the message should stay, and enter a message body. Let me publish the message, and it should have been received by the email. Let me see. Yes, the message has come. So I gave the first message as the subject, and this was the body of the message. Hi everyone, this was the body. So this is how the messages get published to the Amazon SNS topic. So I have just shown you the working that my topic is able to publish the message properly, and the consumers is also getting the messages, they are receiving the messages. This was just a simple configuration for SNS topic. You can configure it as per your requirements, and now it is ready to be used in your architecture. Let's get back to the slides now. So we have seen two types of services under the messaging, that is Amazon SQS and Amazon SNS. But there are a few differences between both of these services, which we will learn about them now. The major difference between when to use Amazon SQS and when to use Amazon SNS is that you can go for SQS when there is only one reader of a message who will process it, and you can go for SNS when there are multiple readers of a message. SQS supports pull mechanism, which means the consumer will have to pull the message from the queue in order to process it. And SNS supports push mechanism, which means the messages published to the topic will be automatically delivered to the subscribers of that topic. They will not have to pull it from the topic in order to process them. SQS has message persistence. It persists a message, whereas in SNS there is no message persistent. Amazon SNS defines a delivery policy for each delivery protocol. The delivery policy defines how Amazon SNS retries the delivery of messages when server-side errors occur. When the delivery policy is exhausted, Amazon SNS stops retrying the delivery and discards the message unless a dead letter queue is attached to the subscription. So you can also use a dead letter queue along with your SNS topic. Then in SQS, there's one producer who sends a message to the queue, which will be pulled and processed by only one consumer. Messages can't be received by multiple receivers at the same time. Any one receiver can receive a message, process and delete it. Other receivers do not receive the same message later, but in SNS, for a single topic, there can be multiple subscribers. In SQS, the entity is the queue where the messages are stored, and in SNS the entity is the topic where the messages are published. The participants in SQS are producer and consumer, where producer sends a message to the queue and consumer consume the message by after pulling it from the queue. In SNS, the participants are publisher and subscriber, where the publisher publishes a message to the topic and subscriber receives it. So this was about Amazon SQS and Amazon SNS, just the basic working of Amazon SQS and Amazon SNS. I hope you would have understood the basic working of both of these services. Thank you.